Hi there, and welcome to my course, SQL for Newcomers. I'm Sameh Sharaf. I'm a data engineer and have been working with relational databases since 2010. In this course, you will learn how to use SQL. Whether you are a student or an employee who needs to work with databases and need to learn SQL and add it to their resume, this course is definitely for you. SQL is a standard language which is essential to work with all popular free and commercial relational databases. If you learn SQL, you're able to use any of those products you see here. This course will use PostgreSQL. Why? Because it's open source, so it's free. It proved to have the best quality performance comparing to other open source relational databases available, and it has good documentation with great explanation for each keyword and function in SQL. If you need to learn more by yourself after this course, it will be quite useful. Okay, without further ado, let's start and hope you enjoy the journey. Happy learning! Okay, let's start by getting and installing the needed applications to begin this course. What are we going to do is, we're going to install a relational database manager or an RDMS like PostgreSQL. Why using PostgreSQL? Well, it's because it's open source, so it's free of charge. It proved its performance and quality comparing to both free and commercial RDMS systems that we have today. And it has a better documentation in case if you need any help, you can simply look into the internet. And there is documentation on its website. Next, we're going to use a SQL editor in order to connect, run, and execute our SQL scripts. What we are using is SQLectron. It proved to be good, it's free, it's open source, it's light, and it has many features that we can use in this course. So let's start together and download and install those two applications. Let's start by downloading PostgreSQL. From Google, I'm going to type PostgreSQL. Here you go. I'm going to check downloads, and from here you can see that PostgreSQL supports multiple operating systems, including Linux, Mac, and Windows. Since I'm using Windows, I'm going to check Windows tab, and from this page you can see what PostgreSQL version is available at the time of this video. It was 10. And as you can see, for version 10, it supports the following 64-bit and 32-bit for those platforms. In case you don't know which Windows version you are using, you can go to the top of the desktop from my computer or this PC icon. You can choose properties. From here, you can see what system type do I have. So, you choose which version of Windows you need to install and download. For me, I have 64-bit operating system, so I'm going to choose this the next time I'm trying to download PostgreSQL. I'm going to download the installer now. And it will direct me to a new page, which is the EDB PostgreSQL project. From here, I will choose enterprisedb.com, which we can download PostgreSQL, and I'm going to choose my version, which is 10.1 for this course, and my operating system as Windows 64-bit. Click download now. Okay, my download is ready, and here is a double click. Next, I will download it into the default directory. I'm going to keep it at and next. Here's the directory where your data will be stored. In case if you uninstalled PostgreSQL in the future, you'll still find your data here to be restored later on. I'll keep the same folder. And here is going to ask us for the super user we're going to use in PostgreSQL. Since we are doing all tasks on our local machine, we can choose any password that we want. Later on, you should consider a very powerful password for yourself when you need to launch any database in the future. This is my password. I type it again. Then next. Here comes the port, 5432. Remember this because we need it later. I'll keep the default one and press next. Here's the locale. If you're using any language other than English, you can use it as your default language for your database. I will keep it the default. And I'll click next. Another next. And here we go. It's going to take some time, so be patient and I may speed up the video. My installation is done. Before that, I'm going to uncheck the Stack Builder option from here since we don't need to open it. I'm going to finish the installation. Here we go. We're all done with installing the database. What we need to do next is installing a SQL editor, which we need to connect to our database and run our SQL scripts. Now let's start with installing the SQL client that we can use to connect to PostgreSQL and run our scripts. From here, I'm going to type SQLectron. It is the editor that we're going to use. From the first link here, we will choose SQLectron and we're going to download the GUI version since we're going to use it on Windows instead of the terminal. SQLectron is an open source and free tool to use and it's available for Linux, Mac and Windows. I'm going to download the GUI and here it will show me the latest version. By the release of this video, I have 1.28. You can find this version based on the time that you are downloading and installing the SQLectron. From here, you can see multiple links for downloads based on your operating system. For Windows, you need to choose the exe file. For Mac, you need to use the DMG, and for Linux, if you're using Debian, it's DEB, and for Ubuntu, it's RPM. There is also the compressed files as well as the source code. We're going for exe and I will select it and download it. After downloading the installer, I'm going to launch it and waiting for it to be finished. And it's done already, and we're going to see the logo. Nice. Alright, we installed SQLectron for now. Let's see how can we connect to the database. In order to connect to PostgreSQL, we need the following information. First, you need the database user. We're going to use the admin user or super user called Postgres. This is the user which you define the password when you install PostgreSQL. Next, you need the database that you will connect to. PostgreSQL allows you to create multiple databases based on your needs. The default database we will be using is also called Postgres. Sounds easy for now. Next, the host. The host is the server which PostgreSQL is installed into. Since we installed PostgreSQL on our local machine, the server will be the local machine, which is localhost or the IP 127.0.0.1. Since localhost is easier for us to use, we're sticking to it. Next, the port, which we defined when we installed PostgreSQL. If you kept the default port, it will be 5432. If you change the port, you can use that as well. Let's see how can we put that in SQLectron. Back to SQLectron. Let's connect to PostgreSQL. From the Add button here, I'm going to click it. And from the information, for the name of connection, you can name it SQL course, or any name that you like. From the database type, we're going to choose PostgreSQL. And from the server address, which is the host, we're going to call it localhost. The port will be 5432. In case you change it, you can get your own. For the user, we're going to use the superuser, which is Postgres, and the password you added when you installed PostgreSQL. Finally, the initial database or key space, which is the database that PostgreSQL created for us, which is Postgres. To test our information, we can click Test and see if it works. And here you go. Connections tested and successfully connected. Click Save, and here we have our connection ready for us. Click Connect, and you are all good. If you see this, then congrats, you're connected to PostgreSQL. Your machine is all ready, and we can start the course. Some students who are using Windows 32-bit are having problems with SQLectron, since it only supports 64-bit. In this video, I'm going to show you how can you download and install an alternative SQL client called DBeaver, which supports 32-bit Windows. From Google, I'm going to type DBeaver, and it's the first link. You can directly go to DBeaver by dbeaver.io. From here, I'm going to go to Download. I'm going to choose the Community Edition since it's the free version, and I'm going to choose Windows 32-bit. I'm going to download it and wait for it until it's being done. And from here, I'm going to use English. You can use any language that you feel comfortable with. You agree. Choose which computer, which is mine. We'll ask again for the language for some reason, and we're going to go to agree again. Here what you need to do is you need to choose the DBeaver community version, and along with the GRE. The GRE is used by the SQL client DBeaver since it's built on Java. Keep those checked. And here you can specify where to install it. Here, if you need any shortcut, and you can say you don't need any shortcut if you don't want to, you can install and wait for it to be done. Your machine may take longer time since my machine is powerful. Not bragging, of course, just like to make sure that if it's slower, it's okay. And you can create a desktop shortcut if you want to. After downloading and installing DBeaver on our machine, I'm going to open it. So the first time you open DBeaver, it may ask you to download a sample dataset or a sample database for DBeaver. So it's free, so you can play around with it using SQLite. We don't care about that for now. What we care about is connecting to Postgres. So from here on the far left, you can see new connection. Click on it and you'll see the databases that DBeaver supports. So from here, what we want to do is PostgreSQL. Not the old one, but the new one. Can go next. And here you can see the default values for the configuration for connecting to PostgreSQL on your machine. If you didn't change anything, so you should see that the host will be localhost, the port will be 5432, the database will be Postgres, and the user will be Postgres as well. So if you didn't do any changes while installing PostgreSQL on your machine, those configurations should be sufficient. Now you can provide the password. And if it's all good, you can test the connection. Since I tried DBeaver before, when you test the connection the first time, it will ask you to download a number of libraries for JRE that is necessary for DBeaver to run. So instead of this pop-up, you can see a window which will show you the libraries and it will ask you to download those. You can just click on download and all is good. Now my connection is success. I'm gonna say finish. So after that, what you're gonna need to do is you need to download the dataset that is attached in your video here or in the previous video. So after you download it, you need to open it from DBeaver. So you say open file. So based where did you download it on your machine, you need to open that file. Here's my file here. Here's the script that you need to run in order to have the dataset that we need to work on this course. I'm going to select everything. You can do it manually, or what you can do is press click, Ctrl, and A. After that, you can click on the execute button here, or you can press Ctrl Enter to run this. It should be all good. To make sure that everything is fine, you can go here into the connection. You can choose Postgres. You can go to schemas, public, tables, and you should see two tables, departments and employees. If you want to run or open a new file for you to work on, you can say new, and you can select only a file here. You click next, and then here you need to choose general as a folder, or you can create a folder if you want. And next you can name it. For example, I will name it test or exercise 1 or lesson 1, whatever you like. And most importantly, you need to call it .SQL in the end, so the DBeaver can recognize it as a SQL file, so you need to run queries. If not, it will show you like a blank file, and yeah, it won't show you the needed execution buttons to run your queries. I'm gonna click finish, and here's a new page. The old page is still there, so the cool thing that you can open as many tabs as you want, so you can work on several pages or several files, and each file can have separate exercises. So I'm gonna show you how can you check if the data is good. So select star from employees. I'm gonna run this using either this or Control Enter, and you can see the data from here. Here's the grid, and here's the data that we have. You can go around and you can see the data. Well, DBeaver gives more features than SQLectron. SQLectron is quite light comparing to this, but yeah, on the other hand, DBeaver is a bit more complicated for starters. Anyway, you will take ahead of this, just take your time, and you can see it's quite simple, it's not that difficult. As long as you reach this level and everything is fine, congrats, you can work with us now. You only need to write your scripts from here, you can execute it using this button, and yeah, you're good to go. Thank you very much for watching. What is a database? A database is a collection of information set and organized so it can be easily accessed, updated, and managed. A relational database or a tabular database is a set of data organized into tables. You can think of tables as spreadsheets, but it's far more complex in design and can hold millions of rows. In order to access the data in relational databases, we use a language called SQL or Structured Query Language, which we will learn in this course. Using SQL language, we can access our data, we can update it, we can run various queries and get all the data that we need from the database. Databases can be used for various catalogs, such as sales, inventories, employee profiles, students' grades, and much more. Any data that you can store structurally, you can use databases. Relational databases are usually managed by a manager system or an engine, which controls database users' access and what can and cannot be accessed by those users, and groups as well as managing data reads and writes, hence the term Relational Database Management System or RDMS. Okay, after we prepared our database and we installed PostgreSQL on our machine, we need some data to experience on and learn in this course. I've generated some random data to use it in this course. You can download it from the attachment in this video. You can find an SQL file, and after that I'm going to show you how to import the data into your database. Let's start by opening SQLectron. Next, connect to your database. Alright. From here we can go to File and up to Open Query. From here I'm going to open the file that I downloaded. Here we go. Here are the file, and those are the scripts that we're going to build our database, our tables, and the data that we're going to use in this course. Don't be scared if you don't understand what is that. We will learn all this eventually. What are you going to do now is you can simply click Execute. Here you go. When it says query run successfully, all this means that every query or every script is written here has been run and done successfully, and seems everything is working and all is good. But you can notice it's when you go from here and you click on the right click on your button on Postgres and refresh the database, you get to see it here and the folder or directory called public. This is the default schema for Postgres. When you open this directory or schema, you can see two tables, departments and employees. If you can see those, it means that you could successfully create the data that we're going to use in this course for now. Alright, let's move to the next section. Okay, so now we're going to start learning SQL. First thing I'm going to do here is I'm closing this tab. We're going to start fresh and I'm going to maximize the window so we can see more. We're going to start together with learning SQL by learning the first statement we need to know. The first statement is called select. What select does, it gets the data that we need from any table that we want, or any query that we require. So select is the main statement in SQL. That we're going to do here is I'm going to show you how to use the select statement in order to get the data that we need from any table. Let's say employees. First, from the editor, I'm going to type select. It is where PostgreSQL can know that get me all the data that I need from the employees table. After select, we're going to show here what columns that we need from this table. Since we have no idea of employees, I'm going to use the star, which is Shift plus 8. Select star means that get me all the columns from a particular table or view or any data source that I am reading from. we get to define what table we're going to read from. So we say after that, from. Then, the name of the table that we need to read from. Now we have two tables, departments and employees is more fun for us, so we will start with that. I'm going to use employees, and I'm gonna type it. That's it. Here I'm telling PostgreSQL to get me all the data from employees table, with all the columns from this table. Let's see the results by clicking execute. Here you go. What you see here is all the data in employees table. Please take note that this data is randomly generated. It's not real data. This is the setup we're going to use in this course, so we have the freedom to do whatever we want with it. So as you can see from the employees table, what we have here are multiple columns from IDs, first names, last names, addresses, states, zip codes, and phones, and other data that we can use later. A table consists of columns like the ID, the first name and last name. It consists of records or rows. Each row, we call it a record because it holds data for an entity. An entity can be anything, like an employee, a customer, a product, a vehicle, or anything that we can define to be an entity or an object to be stored in the database. So for each column and each row, we have a value. Like here, we have first name, like Ili or Joanna, which are employees. Those values of what we need most when we need save or when we query from our database. So we can see that we could select from the table. Alright, since that seems a bit big for us, if we can filter it, or let's say for now, we need to select only certain columns. Like, what I need to see here is the first name, last name, and phone of the employees. So instead of selecting star, here we can name the columns that we need to show and separate each column name by a comma. What you're going to do here is you type first underscore name, comma, last name, comma, phone. So here I selected three columns, first name, last name, and phone. When I execute this query, what I can see here is only those three columns that I defined in this query. First name, last name, and phone. This is cleaner. In case I want to see only the names of those employees and their phone numbers, this is the way you can do that. If you need to call them or connect them or share the information with the HR. It can be anything. Note that SQL is case insensitive, by the way, Means like, whatever character that it's being typed here, capital or small, it's the same and it doesn't matter. So don't worry about that if you type SQL queries. So I'm gonna show you how to type select in all caps and from in all caps, and you see that it returns the same results. For now, we can see the data that we need, or at least we can see the data that we want to work on. Have fun with that and see what data we have for now. We get to move on and talk more about how can we filter our data more and see only the particular rows that we want to report. Okay, before going into filtering our data using the select statement, we get to know something called data types. In SQL, we have three main data types. We have numbers, dates, and strings. Numbers such as salaries, commission rates, or prices are called numbers, and they are stored as numbers in the database. We have dates such as hire dates, which is the database calendar. We have strings. We call the words, the sentences, or any set of alphabet and special characters strings. Strings can be the first and last names, can be emails and job titles. They can also be phone numbers. Phone numbers are not numbers, by the way. They are considered characters because we type them in a way of a simple pattern or format, like using dashes or spaces between the numbers so they can be recognizable and easy to read. When we want to filter the data out in our database, we need to make sure and take care of the data types that we are going to filter on. Sometimes there is a misconception between numbers, dates, and strings that they're not being used correctly. When some users filter the data in the database, they use unoptimized ways to filter the data. Or they have some problems how to filter the data and get the results that they need just because they didn't take a good look at the data they have in the table. So here are the data types SQL provides. We are going to take a look at how to filter based on those data types. Okay, your boss wants some data. Let's say your boss comes to you and asks you to get the data that he or she needs from the database. For example, they may ask who are the employees with the base salary more than or equal to $5,000. Maybe they want to fire them, or for tax purposes, or whatever. Anyway, next, they want to know who are the employees with the base salary between $1,000 and $2,000. Next and last, they need the employees with the salary brackets of $1,600, $2,700, or $4,200. We're going to see together how can we get the data for your boss. Let's go. Let's start with getting the employees with their base salary more than $5,000. Starting from the last select statement that we wrote earlier, we're going to see who are the employees who have such big salary. What we are going to do here is, after typing, select, then the name of the columns which we need to show and from which table we need to read from, which is employees. What we're going to do next is we need to filter the data. Means that we need all the employees with base salaries greater or equal to $5,000. In order to do that, what we're going to do here is we're going to type after the select statement where. After selecting from the table, we want to filter the data. So we're going to type where so we can define what are the filters or conditions that should be applied to filter the records of employees table. After where, we're going to set which column that we want to filter on. If you can see the data here, you will see that the column that is holding the salary or the base salary of those employees is called base_salary. So from here, after we're going to type base_salary, and take note that you should be careful about the column names. It's case insensitive, but doesn't mean you have to drop the underscore, for example, and it should be the same as what is it in the table. Okay, so after we type the column name, what we need to do is, okay, give me the base salary, which is greater than 5,000. So we want to filter those records. And to show the records with the base salary is greater than or equal to 5,000. So I'm gonna type the greater than sign here to say that give me all the data that the employees of base salary greater than 5,000, and I'm typing 5,000. So this query will get us the first name, last name, and phone from the employees where the base salary is greater than 5,000. Let's see what it gets here. I'm gonna execute it now. Here you go. You can see the employees with the salary or the base salaries of greater than 5,000. Cool. There you go. we could answer the first question. But if you can remember, your boss said that they want the base salaries of greater than or equal to $5,000. So we want to also get the employees with base salaries of exactly $5,000. And so how can we do that here? So in SQL, there is a sign called greater than or equal to. So here I'm gonna type the greater than sign, and after that I'm gonna type the equals type. So here it says give me all the records from employees where the base salary is greater than or equal to $5,000. So in this case we covered or included the base salaries of 5,000. You can see that the number of rows have been different. It used to be 77 and now it's 84. So after I executed the query, we can see there is a difference. So we can look for salaries of 5,000. But since here we can't see exactly how much, and yeah, I should have added base underscore salary before. So I've added base underscore salary into the select statement in order to show the column and to make sure that the query returned the right data. And as you can see, all the base salaries here are greater than or equal to 5,000. As you can see, we have Gayla, which her base salary is exactly $5,000. So if I came back here and I removed the equal sign and I executed the query again, and you take a look, you can't find Gayla anymore, since her salary is exactly 5,000 and the query says we want greater than 5,000. So all the salaries here, if you take a look, it starts from $5,100 or $5,100. So it means that you can't find any salaries of 5,000 or below. Okay, so we answered this request now, and here we get the data, and here we used where, so we can filter based on the base salary. We use the sign, which we'll use to filter the data, either greater or less than, or smaller, let's say, from the value that we're doing so. And I'm gonna show you if I used less than or smaller than 5,000, you'll see that all the base salaries now shown is exactly below 5,000. You can take a look. Okay, if you used less than or equal to now, and I run this query again, you can check here if now we included the salaries of 5,000 again. So you may find Gayla again. I'm trying to find her actually. Okay, someone called France has a salary of 5,000. Okay, well, I can't find her. Okay, you can take your time to look it up for me. Anyway, so this is the data that we need, and here's how we can filter our data from any table. Okay, so what if we want all the employees where the big salary doesn't equal $5,000? Okay, so we have a sign in that in SQL. Actually, in maths, if you can remember, what we usually do to represent the net equal sign is that the equal sign with a dash on it. Meanwhile, here we don't have this on our keyboard. So SQL helps us do that by using the less than, greater than signs. Yeah, I know it's a weird sign, but this means that give me all the employees with the base salary doesn't equal 5,000. I'm going to execute this, and I'm going to show you that those are the employees with the base salary is not equal to 5,000. And you can take a look, and you couldn't find Gayla or France anymore here, since their salaries or base salaries is 5,000. And if you want to make sure, you can see that the number of rows here is 386. Meanwhile, if I can run the select statement from all employees without a filter, you can see that the number of rows will be more in this case. And after executing this, you'll see that the number of rows now is 393, which means that we have less records when we run the filter for not equal to 5,000. Okay, great. So let's move on to the next lecture. Going into the next request. Who are the employees with the base salary between $1,000 and $2,000? As we did before, we could answer the first request. Now we're going to the second one. Let's see how can we do it together. Going back to SQLectron, now we're going to filter based on the range that we need, which is between 1,000 and 2,000. To filter based on a range in SQL, what we use is, let's say, a term or a keyword called between. What I'm going to do now is I'm going to use the between keyword after where, which because we need to filter based on a range, which is $1,000 to $2,000. And sure enough, we need to use the column, which is base underscore salary. This is the column that we're going to filter on, as we mentioned before. Now we're going to say that, okay, we need the values between 1,000 and 2,000. And as I'm speaking now, it's the exact same actually in SQL, as simple as that. So I'm going to type between 1,000 and 2,000. I'm going to execute this, and checking the data, you can see that the data that returned from this query is all base salaries of between 1,000 and 2,000, including the values 1,000 and 2,000 as well. As simple as that. We may not ask you to put a semicolon at the end, but I usually do that at the end of each query, because what you can do is, in the same document you can write more than one query and you can separate them by a semicolon, and you can run all the queries at a time, but you can make sure that they don't collide with each other. What I can do also to make the query cleaner is I can break the one query into multiple lines. So as you can see here, it's much easier to read. Here I can understand that, okay, select the first name, last name, phone, and base salary from employees where the base salary is between 1,000 and 2,000. The last request from your boss is, who are the employees with their salary brackets of $1,600, $2,700, or $4,200. This is simple actually, and with a simple trick we can filter based on those values. So let's see how. Okay, so we need to filter based on three values: 1,600, 2,700, and 4,200. If you can look here, we see that we can't use any signs or any other arithmetic sign greater than or less than. They won't work in this case because here we're looking for an exact value. Even the equal sign doesn't work because it will return exactly one value in this case. So if I say base underscore salary is equal to 1,600, I will get the employees with the base salary 1,600, but I won't get the rest of values. And if I use between 1,600 and 4,200, it will get me all the base salaries of between this range. So this won't help either. So what we're going to use here is a new keyword called in. In databases, we can have what we call sets. A set is like a group of values which are different from each other, or we can simply say they are unique. And there is no two values in a set that is similar to each other, or they're equal to each other in this case. So as the same what we have here, we have 1,600, 2,700, and 4,200, which are all unique values or different values from each other. So in SQL, in order to get that, we're going to use a set. So we select the data from employees where the base salary is one of those values in this set. The keyword we're going to use here is in, and I will show you how. This one, I'm going to delete those since I can't keep them here, but instead I'm going to use them here. And since we can filter based on base salary, what I'm going to say is I need all the data from employees with the base salary is in this set. I'll open the parentheses and I'm going to add those values. I'm going to type 1600, comma, 2700, comma, and 4200. I'm going to remove those because they will cause me some problems if I want to execute the query. So what I said here is give me all the employees whose base salary is either 1600, 2700, or 4200. So if I can execute this query and I will take a look at the base salaries here, you will see exactly those three values, 1600, 2700, and 4200. And you won't find any record with value or a salary other than that. Now we want to answer those questions. We want the employee with the last name Alice, employees living in Florida, and employees with the phone number shown here on the screen. In SQL, it's quite simple to get such data, so let's find out. Starting fresh, we're going to check who is the employee with the last name Alice. So I'm going here and type select star, means to show all the columns from the table employees, where here I want to filter by the last name. So I'm going to type last underscore name. To look for strings in SQL, we do the same as we did for dates. We need to use single quotes. Here I'm going to say I need the last name, which is equal to, and open single quotes and then type Alice. I put a string of characters between single quotes because I will show you if I didn't use those quotes. I will execute the query to show you what happens, and you will see that SQL returned an error with the column Alice doesn't exist because it thought that Alice is a column. Let me fix this. I will add the single quotes again and I will execute the query. Here we go. We can see the employee. Her name is Jovita Alice. Please make sure that it's with SQL for strings, they are case sensitive. That means it depends how the string was typed, whether it was all capital or small letters. You use strings as they are in the database or the table you're doing. Here I fixed the O letter again to make it capital letter, run the query again, and you can see we could see the employee again. So now next what we want to do is we want to check the employees from Florida state. So since as you can see from the column we have state, which represents the state of the employee. So we're gonna filter on state is equal to FL, which means Florida. And we can see here now all the employees from Florida state. Sure enough, if I use the small letters here, you think that what results will I get is, sure, I will find no results, since Florida or all the states are represented with 2 capital letters. Next, we're going to look for the phone number provided for us. So since I can't remember the phone number, I'm gonna copy it from the notepad here and I'm gonna paste it. Since you can take a look and you see that we have the column called phone, which represents the phone numbers of the employees, we need to filter using the column phone. So I'm gonna type phone is equal to, and between a single quotes, since phone is a string, I'm gonna paste the phone number. Let's execute this query and we'll see that this employee has this phone number. In the last video, we saw how can we concatenate strings and numbers together. So what we can do is we can form new columns based on multiple columns that we have. For example, here we have the first name and last name, which are string columns. What we can do is we can convert them into one column, which can be called full name. As we did here, you can see that the first name and last name has been joined together to have the full name for each employee. But if you can check it out, the name of the column is a bit quirky. It's not a real name of the column. It depends on what ID are you using or what database are you using, so it can define its own column name in case you're showing a new column in your select statement based on several ones. But what we can do is we can choose our name for the new column that we have created. For example, here we can call this column full name instead of this quirky name here. How can we do this in SQL? It's so simple, and it's called an alias name. We can define aliases as a replacement or alternative name for our columns. So it's not about only creating the new columns based on the select statement, but even the existing columns, you can change their names in case they're not clear, or we want to export it as a report and you want more obvious or more clear names for your boss or for anyone that you're reporting to. So if you want to do an alias for this column and we want to name it full name, it's as simple as that. What we can do is after the column equation, let's say, which will create us the full name column, we will say as, which is a keyword to show that what we want is we want to name this column in a different name or a new name. So after as, I will use double quotes, and it's not single quote. Single quotes is for strings, but double quotes is for column names or for aliases. So here I will say full name. So what I did here is I named this column full name. If I run this query, you will see that the new name now, what we have, is full name. If you want to make sure that everything is right and to make it more clear, what I can do is I can choose several columns here, and I will show you that, as you see, the first name, last name, and full name. Full name is a newly created column that it's the concatenation of first name and last name separated by a space. And sure, to not mix things up, if I do select star from employees and I run this part, you won't find full name here, because what we did is we didn't create a new column and we didn't add it to the table. Just like the select statement, what will show us in this query that we run. So make sure that if you understand that select statement doesn't do any changes on the existing table. It just shows you what formulas or equations that you're doing on this data, which is the cool part about select statement. So you can keep the raw data in your table, and you can do whatever equations, whatever changes or transformations that you need to do so you can show the data, which is the powerful part of databases in general. Have you ever wondered if you can order your records of your report based on a column? Like, I want to be in alphabetic order or I want to sort them by ID or by the net salary, for example. Luckily, in SQL, we can do that quite simply. In SQL, it supports ordering by any column, either a row column that exists in the table, or a column that is a result of equation or a formula or a transformation that we did, as simple as full name or net salary. To do so, what we can do is, after from statement, we can add the new statement, which is order by, and make sure that order and by are separated from each other. It's not one word, it's two words. So this way we can tell SQL that what we want is, we want this query to order the records based on a column or several ones. Let's see how. For example, let's sort our report by full name in alphabetic order. So what we can say is order by full name. Here we don't need to use the double quotes, it's okay. The same as here, by the way. What we can do is, in case your alias is one word, it's okay to not use double quotes. But if your report or your query will have two or more words in the alias, you need to use the double quotes in this case. Anyway, so here I said order by full name. If I run this and check the full name, you will see that it's all now sorted in alphabetical order, starting with A, going to B, going down to Z. So this is sorting as simple as that. We can sort by both strings, dates, or numbers. So if I want to add the numbers, which is for example the net salary, I want to sort by the net salary. So I can come here and say net salary. If I run this again, I'll see that the net salary has been sorted. And as you can see here, we have this web developer intern who's getting the lowest salary between the employees since he's an intern. And going up, we can check that the salary is increasing in this column. Going down, and you can see the highest salary in this company. But well, this is exhausting to go all the 400, about approximately 400 columns or records to see who has the highest salary, if you're so curious. So what we can do is, we can either sort ascendingly or descendingly. Means that we can either sort from the smallest to the biggest, or from biggest to smallest, if it's in case for numbers or dates. In case of strings, as you have for the full name, it can be sorted from A to Z or from Z to A. So how can we do that? If you check this slide, you'll see that order by supports two keywords. The first keyword is the ASC, which is the ascending order, which takes the first three characters of ascending word, which is actually the default one. So you really won't use it anyway because it's the default one in SQL. But what we want to do is the descending order, which is the second keyword, DESC, which means the descending order, the first four characters of descending, which will order or sort the query based on the columns that we specified in a descending order, whether it's a number, so it will be from the largest to the smallest, or for a string to be from Z to A. Let's see together. Coming back to the query, you'll see that the net salary is ordered from smallest to biggest here. But I'm so curious to see who has the biggest salary here in our company, and I'm too lazy to go all the way down. So what we can do here is I can come and say order by net salary, and I will add DESC. which means that order net salary in a descending order from the largest to the smallest. Let's run this, and we can see now who has the biggest salary. So he's the head of data, which means like, okay, they're paying much for data these days. So this is the hugest salary, or the biggest salary we have in the company. And you go down and you see the net salary is going lower and lower because we ordered the report based on the net salary in a descending order. So what about if we want to sort it by full name, but in a descending order? If I run this, we will see that it's now sorted from Z to A. And as you can see, the full name, the first one is Zona, which is the letter Z, then Yvonne, and going down from Y, W, V, etc. So this is how can you sort your records or your data for a query. In this video, we're gonna talk more about order by. So we saw before that we can order our data in ascending or descending order based on any column that we want, either from the table or from the select statement. So here I'm coming again, and what we want is we want to see all the details of our employees in the customer service department or customer care department. So if you can remember from the previous videos, if you still remember, so what we can do is we want to filter by job title. So what we can say is job title, and I want to say that give me all the employees who are working in the customer department. So we can use I-like, since if you can remember, I-like is for case insensitive cases. So instead of taking care that customer is a capital letter or smaller letter, we can use I-like so we can avoid this problem. Next, we're gonna use single quotes for strings, and I'm gonna use the percentage sign. Just remember that the percentage sign for strings, it's about giving a character or more if you're looking for characters, while in math the percentage sign is for the modulo operation, just to make sure that you differentiate between the two cases. Anyway, so look for everything with the port customer. If I run this, you'll see that it gives me all the employees working in the customer care or customer service. Okay, so what we want is, next I want to order this data. So I want to order it on several attributes. So the first thing, I want to order them by job title, and next I want to order them by name. So in this case, I can order first the job titles instead of having a random or a messy report. So I can order them so it can look more better. So in case it will be easier for the one who's using the report to see that all those from the same team or the same department for the customer division, let's say. So always remember that the order by comes last in the select query. So when you write the select statement, first comes the select, you select your columns, then the table name in the from, then the filtering using the where clause, and finally comes the order. So I say order by, and then I will say and to order it by job title. If I run this, now it will be ordered by the job title. At first by the customer care manager. Going down, you'll see we have the customer care operator, which is because M is before O, so manager is before operator. Going down, and you will see that it's ordered by alphabetical order. And sure, if I use the descending order, which is this one, it will be the opposite. Checking out, and you see that customer service, which is S. Then if you go down more, you will see that it will be the customer relationship, which is R. So the alphabetical order is from Z to A. Anyway, so first I want to sort it by job title. Next, if you see the report more, you see that, okay, we sorted everything by job title, but you see the full name is a bit, yeah, it's a bit messy. So what we can do is we can order by full name next. So in case we have two records with the same job title, we will order the one with the full name in an ascending order. So I can add here, using the comma, I can add full name. And if I put ASC, or I didn't put it, as we mentioned in the last video, the ascending order is the default one. But I will keep it to show you that it will work either way. So now, in this query, I'm ordering first by job title, then by the full name. And as you can see, we have first the customer care manager, then the operator. Okay, so when we have two records with the same job title, you'll see that the full name will be ordered first. So first it will be Ahmad, then Eliza, then Lily, then Mitsu. So as you can see, you have the letter A, AL, then Lily with L, and Mitsu with M. So it will sort first by job title, next by full name. What we can do also is, to make it better, is that maybe instead of full name, we can order by the net salary in a descending order. So what we'll have here is the job title will be ordered first, then the net salary. I have a problem here, which is, okay, net salary doesn't exist because, as you can see here, I had a problem which, because of the net salary. If you see my query, the net salary here doesn't exist. So it simply didn't know what is the net salary. So I'll fix my query by adding net salary here, so it will work again. The cool thing about order is that it uses the alias. What we can see next is, unfortunately, where clause can't use the order or the alias. Sorry, I'll show you an example about this later on. So anyway, so here I have the net salary, and if I come here, you'll see that now we ordered by job title first, then by the net salary. So you'll see that for the records with the same job title, we're having the net salary, which is the highest first. So for the customer care manager, we have the highest, then to the lowest. Then if the operator will be having the highest and the lowest, and the same thing over and over. Sure, the data is quite random and it doesn't represent any real data, so you can get some wacky salaries, like an operator getting very high salaries for even American standards. Anyway, so this is how you can order, even ascendingly or descendingly. So just, you can specify descending, so it will order this column in the descending order. And if you don't specify anything, or you can just mention ASC, or means the ascending order, it will order it in an ascending order, which is, yeah, this keyword is quite useless and nobody uses it because it's the default one. But yeah, it's there, so you need to know if you need it, or even if you read it one day in some query. Maybe some people like to add it because it will show that, okay, I'm adding this in an ascending order while the next column in descending order. And sure, you can order as many columns as you want. For example, what I can show is, I'm gonna add hiring dates here to show you that we can order by dates as well and timestamps. So what we can do is, I will add here the hire dates. So what happens is, from this now, it will order first by the job title, and in case you have the same job title between two records, it will be the hire date. And as you can see, the hire date is working, so first is 2002, then 2005, then 2006. If you can check the operator, it starts with 97, then 98, etc. And in case you have, let's see that, show you that it can order by several columns, I will use the base salary to make it easier for us, because since it's very hard to find two employees with the same net salary. So if I go here and I will check out, I want two employees with the same base salary. So later on, you can check that in case if you have, if you have two employees with the same hire dates, in this case, if they've been hired together, so it will for next order by the base salary in this case. So and I'm gonna show the base salary here just for let's see if we have anyone with the same base salary. Okay, so if you check it out, now what I'm doing here is, if you check the order by, so it's first by job title, the base salary, and the hire date. What does it mean is, in case if I ordered by job title and they are the same, it will order next by the base salary. And in case we have two employees with the same base salary, so it will order next by the hire date. So let's check together if we can find someone. Okay, so it's very difficult even to find the same base salary here. Oh, here we go. So we can check this one. So we have Letty and Alicia. So for Letty and Alicia, they're working together in the customer care operator team. And what they have is the same base salary, which is 4,200. But what happens is, for Rashida as well. So we have three people with the same job title, which is the customer care operator, and the same base salary, which is 4,200. So as you can see here, we have two columns with the same values. So as we ordered here, we have the job title, we have the base salary, and next one is the hire date. So we'll check out that in case the job title and the base salary has been the same values, equal to each other, the third one will be the hire date, which we can check here between them, all those three. And as you can see, first it was Rashida, which was hired in 2003. Next it was Letty in 2005, and Alicia with 2011. So here's a good example that you can order by several metrics or several columns. So in case the first column was equal to each other, it will order by the second. If the second was equal, it will be ordered by the third, either ascending or descending, depending what did you mention here, etc. So this is how the ordering works. As simple as that. It's quite cool and it's quite easy. And yeah, it's like very simple, but at the same time, it will give you a very good report and a very tidy report based on what you need. When we run a query like this, which is select star from employees, this query will give us all the records in this table. Now it depends on the IDE or the tool that you're using to connect to your database, whether it's Toad, it's SQLectron, it's MySQL server, everything that can depends on which IDE you're doing. It can limit your number of records you bring in there, because now our data is only like less than 400 records here. But what if you have a table with millions and millions of records? You can imagine that this will consume much RAM even in your machine, and it will crash because it will be much memory allocated to show you all those records. It happens often that, especially now we are in the big data era, which millions of records is now quite the norm when you work on any medium to large project. So what you need to make sure is you don't need to consume much of your data and make your relational database quite, exhausted by bringing you all the data that you need, especially if you have a query that is quite complex, much mathematical calculations, for example, and many columns. this all like, it has an effect on how much time does your query take. Here our data is quite small, so it's quite fast. It's taking milliseconds. But when you have millions of records, this may take minutes, even sometimes hours if your query is very bad. So what you need to do is there's a way to limit the number of records that you're bringing from the database. This can be very cool and very easy. It makes your database administrator quite happy that instead of reaching 100,000 records and consuming the original database's resources, banning anyone else from using it, you can simply get the first 1,000 or the first 100 records, and even the first 10 records in case you want to check the data of any table you don't have an idea about in the first place. So one is quite simple. So how should it be working is, you can simply, when you write your query, at the end of the query, you can limit the number of records to be obtained from your database or from your table. So here I'm gonna, for example, limit it by 10. So here you can give the keyword limit and you can give a number which indicates how many records should be obtained based on the query. So if I run this, you'll see that I only brought 10 rows or 10 records from the table employees in this case, which can be faster. If you can check that 10 records took much faster than, let's say, the whole table. And we're talking about a table of 400 records here. So you can imagine if you have a table with 1,000,000 records, how much time will it take and how much resources you will consume. So always keep in mind to use limit when you use tables with such big data, let's say. For the limit, it should always be at the end of your statements. So for example, if I have where, and let's say, for example, the base salary is bigger than 3,000, and okay, order by, let's say, the first name. So the limit should be at the end, after order, as you can see. So if I run this, here you go. So it brings me all the employees who are the base salary is over 3,000, and it ordered by first name, as you can see here, and it's only the first 10 records. So this can be very, very useful. For example, okay, I want the top 10 employees with the highest salary. We can do that. Sure, there are other metrics to do this, but this is the easiest way to do so. And I see many analysts, data analysts, and even developers do that. Instead of going to the more complicated. It's not very complicated, but yeah, it's the easiest one to get when you want to get a query the fastest possible. So let's see. Okay, I want the top 10 employees in my company. So what I can say is order by the base salary or the net salary, let's say. To make it easier, it's the base salary for now. We won't go into the whole equation thing. And order in a descending order, so it will bring from the top to the down, and limit by 10. And to make it easier, I just bring the first name, last name, and we will see the base. I want to see the title, so let's see the title. We can't see the states, and finally the base salary, which is we need to know how much. So I will run this and we will see that it gives me the base salaries, the top 10 in my company. So we'll see the base salary, the top base salary is $9,500, which is for a CIO. They're paying much for information technology from Oregon. And we'll see the next one will be 8,500. It's the revenue accounting and controls chef. I don't know what is that, but it seems like a big thing. So yeah, like as you can see, the heads of departments and chief officers, the C-level are having the highest salaries, which is, yeah, understandable. So this is how limit can work. It can be by everything, top three. There we go. So for example, I want the top three from a certain state, where state is equal to New York. So here's something wrong, which is where. And as you can see, this is a good example to show you that if you mix between the order, or sorry, between, yeah, the order of your query, that order by is before where, it won't work. SQL is not flexible with that, actually. So first it should be the where, then the order, then the limit. From this again, I will see the top three in New York, the top base salaries. And as you can see, all three are from New York. This is the job title for each one, and the base salary. I'll show you that limit can be anywhere. So if I put it, like, for example, before where or before order, yeah, as you can see, it will return a problem or an error. So always remember now, since what we took is select from where, order, and limit for now. So we have those 5 statements. It should be by this order. We're going to talk about null values. What is a null value anyway? A null value is simply a field that has no value. We call it a null value. For example, in some cases, maybe when we set and insert the employee's details into our database, some of those fields are missing, like for example the phone number. So in this case, we can set this field as empty or as null, let's say, to be updated later on. So this can be useful, so we can check what values are missing, so the HR department can follow up with the employees and they can fill it up later. We can see an example here, and we're gonna check our data for the employees table. So what I know that in our data, some phone numbers are missing for some employees. So what I'm gonna do is I'm gonna say where the phone, and here if I want to filter by the null values, I can say equals null. This one doesn't work. It depends on what database you're using. In this case, it will just return no values, which is wrong in our case. In Oracle, it will return an error value, an error that says that you can use the equal sign with null. So what you need to do is always when you use null, you say is null. And always remember this. So when you use null in the where clause, you use phone or the column is null or is not null. So if I run this, you will see that here we have the phone numbers as null. And again, null is not a value. It's not a string. It's just a no value, a nil. So here, only the UI will show you that we have a value which is null here. So it can help you detect that those columns, those records, it has a null value in the column phone. Sometimes it depends on each IDE you're using or UI. It may be like be a blank, a gray square, a yellow square. It depends what UI are you using. In SQLectron, it shows you as a gray box with a null value inside it. So anyway, it will help us say that, okay, we have those 4 records and 4 employees with no phone numbers, so we can fix that. And to show you that the phone or the string, the null value, is different from an empty string, which many people may fall to this trap, I will show you if we say where phone is equal to an empty string. So I just open and close single quotes, which means that I'm looking for an empty string. If I run this, you'll see that I have 3 employees with empty strings. This might happen sometimes, depends on how the developer is programmed the platform, so it can store empty values, let's say. Maybe it's like, yeah, something related to development side. It's not related to the end users. Sometimes end users put spaces, for example. It may happen. So there are measures that should be taken when storing data into our databases. So we need to keep it as clean as possible. So anyway, this one can be confusing. This case can be happen a lot. So don't think that you won't see it anywhere. Sadly, it's like a frequent use case. So what I want to do here is I want to see all the records with missing phone numbers. So I will say it's either the phone is equal to an empty string, which is a single quote with no values, or the phone is null. So you'll see that actually I have 7 records with no phone number. So in this case, what we can do is we can report the HR department to check with those employees to provide them with the phone number so we can later on update their records in our database in this case. So what you can do is we can select the ID, the first name and last name for those employees, in addition to, let's say, the job title. So in this case, okay, we can report this to our HR department so they can check the phone numbers and get the phone numbers to be updated later. Okay, finally, we're gonna start a new section, which is functions. So what is a function? Actually, functions give us much capabilities in SQL since we can do things that we can't do before. For example, if you want the sum amount of the net salaries for all the employees, or we can get the count of employees for a certain state, or we want to know the maximum or minimum base salaries per state, for example, or per zip code for other statistics. What we can do also is we can trim or clean up our data. Like, for example, if we have names with no caps, we can fix that. We can trim any spaces if it's before or after the addresses, let's say, or job titles. Such things we can do in normal SQL or what we did so far, so functions can help us do so. There are many functions, they're predefined in SQL and they're gonna help us. So what is a function anyway? A function, we can say it's like a black box that they are a set of instructions inside. So when we give it an input, which can be one argument or more, it will give us exactly one output. So we can check for examples. This may be scary that for people who don't like maths, but it's quite simple. So for example, in the first box, we have a function which takes x as an argument and returns x times 2. So if we give it x equals 3, so the output will be 6. For the second function below, we can see it takes 2 arguments, x and y. So what it returns is x times y. So if we send x as 4 and y as 3, the output will be 12. So what the type of functions that we have in SQL? We have 2 types of functions in SQL. We have single row functions and multiple row functions. As an example for single row functions, they are the functions that they are executed per row or per record. For example, if we have 2 records on the left, which are for Sam and David, if you apply the function called upper, what it does is it makes all the characters in caps. So as you can see from the left to right, you'll see that the names Sam and David are now all caps. This is a sample of a single row function. What about a multiple row function? A multiple row function is that it takes all the records field as an input, and as an output it will give us exactly one value, which depends on what function did we use. For example, there's a multiple row function called sum, which gives us the sum amounts or the sum of all the values for a certain field. Let's say we have the field called amount here, which has those values as we see 500, 300, 200, and 700. If we apply sum on the field amount, we will see that it will return the value 700. So this is the difference between single row and multiple row functions. In the next video, we're gonna start with multiple row functions because they're quite more useful, let's say, or yeah, it's very useful to know them first since you can do many stuff with those. And we will go eventually with single row functions and learn what functions and what type of functions do we have in SQL. In the last video, we talked about what is a function and what type of functions do we have in SQL, which are two types, multiple row functions and single row functions. We're going to start with multiple row functions in SQL, and we're going to play with 5 functions which are the main multiple row functions in SQL. They are sum, the average, count, min, and max. Please note that those are the most important functions for multiple row functions. And the first 3, you're gonna use them a lot. So make sure you can understand how do they work. They're quite simple and quite easy and quite fun. Getting back to SQLectron, what we're going to do is we're gonna apply the multiple row functions we saw in the last slide into our table employees. And we're gonna start with the function sum. What sum does is it gets us all the total value for a certain field. And sum only takes numeric fields, means that only fields with numbers. So since it does the addition on all the records for this field. So since for our table we have base salary as a numeric value here. So we're gonna say that what we want is we want the total base salary for all the employees in this table. How can we use the sum function? What we come here is we come to the select statement and we say sum, we define what function do we need to use, and then we need to pass the arguments of this function so it can give us the output, which is the total amount or the total base salary in this case. So we will open parentheses, and inside the parentheses we need to say what argument or what arguments, depends on the function and how many arguments does it take, we need to pass or we need to calculate. So sum takes only one argument, which is the field that it will give us the total value of, or the total value of all the records. So we're gonna pass the base salary, which is the field that we're interested to see the total amount of. So this is it. What we did is we defined what function to use, we open parentheses, and we pass the argument or the arguments that this function needs to return the output that we're looking for. So this function or this query will return the total base salary for all employees. Let's run this and we'll see what it gives us. As you can see here, this is the total amount of all the base salaries for the employees in this table, which is $1,362,800. So this is sum, as simple as that. Let's make it more fun, and let's say that okay, I want the sum total, the base salary for a certain, let's say, state. So I can say where state is equal to Washington. If I run this, you will see that the total base salary for the employees stated in Washington is $22,500. We can use New York, for example, or California, since I think we have many employees from there, and you can see it's more than what we have in Washington, which is 189,000. So here's how the sum function works. Now to the next function, which is called the average. What average does is it gives us the average numeric value for certain values in a certain field. For example, we want to see the average base salary for all employees in our table. So what we can do is the same way we did with sum. We say select, and then we call the function average, which is named AVG in SQL as an abbreviation or short for average. So next, we open parentheses so we can send the argument that, or the field that we need its average, which is in our case the base salary. From which table? From employees. As simple as that. We run this. So we run the query and we see that it returns the average of all the base salaries that we have for all the employees in the company, which is by average $3,400 or about $3,500. And you can see it's a real number or a float number, since it should return the real average and not only an approximation, since this function is used a lot for calculation and for averages if we want to calculate the mean or the median in later functions. So here it's quite simple. As you can see, the same way we used with sum, we use with average. And what we can do also is we can filter by states, and we can say we want everything from New Jersey, for example. We want to see the basic salary of the average base salary in New Jersey. And here you go, you can see that the average salary is a bit higher than the average salary for all the company. As you can see, this can be very useful for comparison if you want to look for the average salaries and the median ones among the states. We'll see later how can we see for all the states and not only for a certain state using the group by. So we're gonna focus now on checking all the functions first, and the cool part is I can use both average and sum at the same time, so we can do something like that. So here what I'm doing now is I'll be having two columns, one for the average and the second one is for the sum. So we will see both values at the same time, so I don't need to run two queries in this case. So as you can see here, I got the sum base salary for New Jersey, which is 145,200, and I have the average as well. And the cool part, I can, for example, I can get in, like, okay, I want everything that is in, let's say, Florida, and we can say Colorado. And we run this, and we can have the sum for both states, and we can check it out, the average, how it is. What we can do also is you can fix the alias for those, like instead of having this auto-generated alias, we can do as, and we can call it, you can use this one, average base salary or base sal. And here you can say as sum base salary. If I run this, you see that we could fix the alias for the result of our query, select query here. So yeah, it's nice. Now we're gonna talk about the count function. What the count function does is it counts the occurrences of values in a certain field. So this one can be quite simple and quite straightforward. What I'm going to do here is I'm going to use the count, and let's see that, okay, we want to count how many values in a certain field or a certain column. Let's say, for example, count first name. So what we're going to do here is we're going to count how many first names do we have in Colorado and Florida, which means that we're counting how many employees actually do we have in those states. If I run this, you will see that we have 31 employees in the states of Colorado and Florida. If I remove this and we'll check it out, how many do we have? We have 393. And you can check it out that it's true if you go and simply say select star from employees. You'll see that we have 393. So the count is very useful if you want to count how many fields or how many records we have, for example. So for a certain table, any table like orders, students, books, so you can simply count how many books do we have, how many employees, how many students, how many cars. So yeah, the count is like to count the occurrences of how many items do we have in a certain field. You can count the whole table, which, okay, for our example, the same way we counted for first name, you can simply make it more general by saying select count and then use star. So in this case, what you can do is you can count how many records are in a certain table. So this one is quite used a lot because simply people want to know how many records we have in a certain table. So even if you have a huge table and you want to know how many records we have, you use count star, and you'll see it will return us the total number of records. And maybe someone will say that, okay, I can't depend on this. Actually, this one is supported by the UI or the IDE, SQLectron. But the thing is, you may not see this when you use the command line, the terminal, or any other UI, because sometimes it can be too expensive if the table is huge. So let's take another example. What you can do is you need to remember that for count, it doesn't count the null values. If you can remember from the last video, we talked about null values. So when we have a null value, you can't use count, or let's say count won't count it, to say the least. If you can remember, let's see, we have select phone where phone is null. So we checked together and we found we have 4 records with the phone number as null. So if I come here and I say count phone, as you can see, it will return 0. Although, like we saw earlier, that we had 4 fields or 4 records, right? The thing is, count doesn't count the null values. Remember this. So the same, for example, if you can say, and I'll show you that if I say the select counts for phone in the whole table, you'll see that it's missing. We saw that we have 393, and what I can show you is I can do this count star. So we can compare between the total values. Oh, okay, sorry. Here in SQLectron, in case you're using more than count, you need to use an alias. It's a weakness, or it's a bug in SQLectron, or let's say a limitation. Anyway, so count all, and I'm gonna call this count as count phone. So here, the count phone, we have 389 phones, but the total employees are 393, which means that we have 4 phones with the values of null. And you make sure that there's a difference, since it could count the empty ones, which means if I say select phone where phone is an empty string, you'll see that we have three records with empty phone, which is like can be a space, or here in our case just empty. And we mentioned before that it can be due to development, or any case that, okay, it entered an empty string, which is different than null. Anyway, this is count, and this is how it works. So what you can do is a count here. If you return back and we want to see the total, so we can say now we need the count star, or which counts all the employees. We have the sum for the base salary, and what we have is also the average for the base salary. So here, so far we took 3 functions and we can see that we have 393 employees with a some base salary of 1,362,000 and an average of 33,467 or $68 approximately. So we see 3 functions so far. Those 3 are the most important. Keep them in mind. The other 2 are less used. They're important as well, which are min and max. But keep in mind that those functions are quite useful. So keep them in your mind, and they can be very useful in your career or in your studies. Let's answer this question. How many employees do we have per state? So let's see, how can we do this in SQL? If only we had a function that can count how many employees do we have, which we do, which is the function count. Let's see how can we do that. Getting back to SQLectron, let's see how can we count how many employees do we have per state. We saw earlier that what we can do is we can count how many employees in the whole table, and it's 393. But what do they want is how many employees do we have in each state? They want to know how many do we have in New York, New Jersey, California, Colorado, Florida, etc. So what will you do in this case? You think it's a good idea to do this every time? Sure, you can do that, but since we have about 45 states stored in employees table, that will take like 45 queries, and that will take you at least 45 minutes to do that, while you can do that in 1 minute. Let's see how. What we can do is, since we want the state here, so we need to show the state. And then what we can do is we can use count and star. So do you think that using count state will work? What we want is we want to count how many employees, means how many records do we have per state. So here what we're doing is we're gonna count how many employees do we have per state, and from our table, which is employees, and this will give an error. The error says that the column state, which is in employees table, must appear in a group by clause. What does this mean anyway? When we mentioned that we want to see the how many employees do we have, or the count of employees that we have in the table per state, we need to say to SQL that the counting is based on state, which we can say it's the dimension of the query. What do we mean by dimension is that, okay, the metrics that we want to take here, which is the count, on what dimension that we want this count to be based on. When we have no dimension, usually it's the total number of records. But here what we want is, we want to say that give me the count of records per state. So to mention that, for SQL to know that it should be per state, we need to define that in a new clause called group by. So here what I need to do is I'm going to remove the semicolon, and after from employees I'm gonna say group by. Here I can define what dimensions that I want to apply the count on. Here, for example, we want the state. So group by state. So in this case, the SQL query will count how many employees or how many records do we have in the table employees per state. Let's run this and see what happens. And here's the magic. You see here that the SQL query counted how many records, which represents the employees we have in the table, per state. And if you check here, you'll see that for California we have 55 employees, which I think they are the most that we have. You can check later if you want. And you can check for Texas, for example, we have 26. For Ohio, we have 17. For New York, we have 34, and etc. So this is the magic of grouping and using group by with the multiple row functions, that we can do calculations or analysis in a very easy way. And here what we could do is we know how many employees do we have per state. Sure, you don't need to put state here, but as you can see, yep, we can see what state is this. Like the data is, we can't understand it. It's useless because I don't know for each count, like 55, for which state does it belong to. So it's not about what do you put in the select statement, but what do you put in the group by clause. So since we defined that the group by clause will be based on state, it will do the grouping for us and count for us based on the states. But sure, for us, we need to see it in the end. So what we need to do is we need to say states and along with the multiple row function that we're using here, which is the count. So run it again, and we can see per state how many employees do we have. Change of plans. Since now they saw how can we easily do finding the count of employees per state, now what they want is we want to know how many employees do we have per state and job title. Means that, okay, we want to count how many employees do we have in per state, and depends on the job title, we need to count how many employees we have holding the same job title on each state. For example, how many customer care representative do we have in California? Or how many software engineers do we have in Washington? Getting back to our query from the last video, here we will see how can we add the job title as another dimension in our query in order to see the count of employees per state and job title as mentioned in the last slide. So here we can simply add the column job title to the group by and sure to the select statement so we can see it as well. And let's see, here we can see that now we can see how many employees do we have per state per job title, and it might be mostly 1 or 2, so we can look it up here, which can be a bit difficult. So let's do some sorting and ordering so our script can be easier to read, or our results can be easier to read. Let's say, for example, I want to see what are the most job titles being hired in our company. So what we can do is, first, what I'm doing here is I'm gonna give it an alias name for the count star, since it will be easier this way. And then what I want to do is I want to order the data descendingly by the count all. So here what I can do is order by, and I'm using count all, and in order to sort the data in a descending order, if you can remember, we use DESC, which is for descending. And let's see. As you can see here, the most hired job title in the company is an accountant based in California. And we saw that by the first record that we have here. If you can do something like that, limit 1, and we can see only one record in this case, which can be more clear. So running this back, and we can see how many employees do we have per job title per state. If you want to make it cleaner, we can order not only by count all, but what we can do is we can order by job title and then by state. So first, what is going to happen is it will order by the count in a descending order. And if two records have the same count, it will order by job title. And if it happens that they have the same job title, it will be the state. If I run this again, we will see that now we can see a little better and cleaner data. Ordered first by counting in a descending order, then job title in alphabet order, and the state in alphabet order as well. But sure, as you can see, since the counting is first, so you can, the state alone can, it appears like it's random, but actually it's ordered. So you can see, like, for example, if you can go down, you'll see here that when we have software engineers from different states, this one is from California and this one is from Florida. So the one from California came first since the state is applied for a sorting. So California came before Florida. Yep, this one is like we already talked about in order by video, but yeah, I'd like to remind you about it and how can we use order for such queries. So that's it for counts. And like, yeah, we can see how can we use sum, min, max, average on grouping as well. Thank you very much for enrolling in this course. I hope this crash course was enjoyable and helpful enough to learn SQL and put you on track. If you have any questions or need any help, you can always post in the Q&A section. Now, since you reached this far in learning SQL, I bet you're hungry for more. For that, I have prepared a full mastery course which you will find over 11 hours of video lectures, with the same high quality as the lectures you just finished, but with much more topics and examples to practice and master SQL. My full mastery course is being updated monthly, and over 11,000 students are enrolled by the time of this video and counting. Since life is too short to wait for the next Udemy sale, I will offer you a great deal. You can get the SQL Mastery course for 75% off. Just use the voucher code shown here and you're good to go. See you there soon. This is Sameh Sharaf. Wish you all the best in your learning journey. Happy learning.